Hi, my name is Shane Britt and I'm here at Granada Farms in Wheelock, Texas. I have a friend with me, Down and Dash, and today we're going to explain carbohydrate utilization in the equine diet. While our culture is so caught up in fad diets ranging from low fat to low carb to high protein diets, carbohydrates are vital in the equine diet. Though horses are monogastric animals like us, they digest nutrients very differently from humans, so it is important to remember that the next time I am on a low carb diet, my horse remains on their high carb diet. It is critical that we feed our horses properly because we can cause serious temporary and lifelong issues during growth and maintenance due to a nutrient ratio imbalance, nutrient deficiency, and/or overload of a nutrient. Our horses are super tuned athletes, so with correct feeding we can optimize our young horses' growth potential and our adult horses' maintenance and performance. In this video I would like to explain what a carbohydrate is, where they come from, why horses need them, and how Down and Dash can utilize and digest carbohydrates. I will also discuss the benefits and negative aspects of carbohydrates for Down and Dash based on our domesticated feeding routine. One of the first questions you should ask yourself is, what is a carbohydrate? First, a carbohydrate provides energy to our horses. Without carbohydrates, horses would not be able to perform like we ask them to. A carbohydrate, often abbreviated as CHO, is a molecule made up of mostly carbon, hydrogen, and oxygen in a 1:2:1 ratio respectively, with 1 carbon, 2 hydrogen, and 1 oxygen. There are 3 kinds of carbohydrates, but for now we will just focus on non-structural and structural carbohydrates. Sugars and starch make up non-structural carbohydrates. Sugars, also known as saccharides, come in all sizes. Monosaccharides, most importantly glucose, are molecules with 1 sugar unit in the molecule, hence the prefix mono. Glucose is the most important monosaccharide because this is the preferred energy source by most tissue in the horse's body. Glucose is a component of starch, cellulose, and glycogen. It is also the end product of non-structural carbohydrate enzymatic digestion in the small intestine and non-structural carbohydrate fermentative digestion in the cecum and absorbed as such. So the body can take a large saccharide and break it down into glucose and absorb glucose and store it as a glycogen, which is a starch. Glycogen can then be converted back to glucose and used for anaerobic exercise like sprinting. The horse's body can only store so much glycogen at one time though, so this is where feeding routine becomes important for our sprinting horses. Structural carbohydrates are made up of a combination of cellulose, hemicellulose, and pectin. These are all polysaccharides, meaning they have 10 plus sugar units in the molecule. Structural carbs are ingested from forages or any plant material. On your feed tags, these are simply represented by the listed crude fiber value. There's a little more that goes into this value, but we will keep it simple for now. Said structural carbs are only digested and absorbed via fermentation in the hindgut due to their chemical bonds that only microbial enzymes have the capability to denature. The end product of fermentation as structural carbs are volatile fatty acids. These are useful for anaerobic exercise or endurance type of events. Starch is classified as a polysaccharide. It consists of 10 plus sugar molecules bound together. It is the principal sugar form in cereal grains. There are a few types of starches, but glycogen is the most important. The second question we should be asking when feeding our horses is, how is my horse going to digest this nutrient? In this case, how will Down and Dash digest carbohydrates? The GI tract is divided up into the foregut and the hindgut. The foregut consists of the stomach and the small intestine. This is where enzymatic digestion takes place. The hindgut is home to the large intestine, and the large intestine, specifically the cecum, is where the bacteria and the protozoa ferment feedstuffs to break down and absorb nutrients that the enzymes in the foregut could not digest. Obviously, when a horse ingests feedstuffs, the first stop is the mouth. The physical presence of feedstuffs simulates saliva production. The saliva in a horse contains very little to no enzymatic activity, which simply means it does nothing to break down nutrients to smaller components. When swallowed, the esophagus transports food from the mouth to the cardiac region of the stomach by muscular contractions. Although the stomach has some fermentative and enzymatic capacity for other nutrients, the stomach does very little for the digestion of carbohydrates. The equine stomach is very susceptible to gastric ulcers because of the sloshing effect due to the design of the stomach. The stomach is connected to the small intestine via the pyloric sphincter. The small intestine is approximately 30% of the adult GI tract. The small intestine is the site of sugar and starch digestion and absorption. The enzymes present in the small intestine have no capability to break the bonds and digest structural carbohydrates. The small intestine has 3 sections: the duodenum, the jejunum, and the ileum. The duodenum attaches to the stomach, the ileum attaches to the cecum of the large intestine, and the jejunum is between the two. It is the majority of the small intestine and is the primary site of absorption of nutrients. The partially digested excess non-structural carbs, which are sugars and starch, and the undigested structural carbs pass from the small intestine to the large intestine via the ileocecal junction. The large intestine is divided into three sections: the cecum, the large colon, and the small colon. The cecum is vital to the horse. It is 3 to 4 feet in length and slows the rate of passage of feedstuffs to allow the GI tract more time to digest and absorb nutrients. It serves as the only form of fermentative digestion by our microbial populations in the hindgut, which is very important to break down the structural carbs that we see in our forages. With the fermentation of non-structural and structural carbs, the horse absorbs volatile fatty acids. Oftentimes, we forget that even though our horses are born and bred in a domestic setting, their digestive system is not adapted to the processed and concentrated feeds that we provide to them. Their GI tract functions like they are grazing grass here and there for 18 hours a day. They aren't meant to see the amount of glucose that we provide to them. This is why laminitis is somewhat of a man-made problem. The biggest challenge when feeding our horses is increasing pre-cecal digestibility. In a feral setting, horses do not see much starch. Because of this, there is very low amylase activity, and amylase is the enzyme that breaks starch down into smaller and more digestible components. Too much undigested sugars and starch enter the cecum of the large intestine. This is what we call starch overload. This can have very serious effects because the pH in the cecum becomes acidic. This contributes to colic and laminitis. With this low pH, we begin to lose variation of bacteria to ferment, thus losing the ability to make other nutrients. In order to avoid CHO overload, it is best to feed horses a smaller and more frequent concentrate meals to increase pre-cecal digestibility and maintain the bacteria in the hindgut. Insulin resistance is something more natural to the horse. After non-structural carbs are ingested, the horse breaks these carbs into glucose. In response to glucose, the pancreas excretes insulin, which will mobilize and store the glucose. In an IR horse, the pancreas is overactive and the body essentially ignores the signals to mobilize glucose. The cycle is never ending because as the body is ignoring the insulin, the pancreas continues to excrete insulin. This occurs in a domestic setting when you have an obese or older horse, not when your horse is getting enough adequate exercise. There are a few things to consider when feeding your horses. Forage is the foundation of your horse's diet. Your horse should receive an absolute minimum of 1% of their body weight in forage daily. Get your pasture and forage tested to see what nutrients are available to your horses. After testing, concentrate should only be added to your horse's diet to fill the gaps that your forage cannot supply to your horse. Your horse should receive no more than 0.5% body weight in concentrate per meal. Consider your horse's stages of life, whether it be a growing horse, a performing horse, a mare in gestation or lactation, a breeding stallion, or a maintenance horse. Not every horse is the same, and take advantage of your nutritionists at universities, online, or at your local feed suppliers. There's much more information out there than what was covered in this video. Lastly, pay attention to what your horse is telling you. If they are dragging during exercise, they may need more energy. If your horse is obese, pay attention to their exercise and concentrate intake. Thank you for watching the video. I hope it helped you understand carbohydrates in the equine diet.